So let's look at the manual for QSub. So this manual is quite descriptive, and I suggest you read it completely to understand what all QSub directives are available. So for example, it will say that some environment variables are available in QSub. So when you run QSub, what happens is you are asking that script to be sent to a compute job. So it may happen that your bash shell that you are using to send the commands from the head node to the compute node through the QSub, the PBS script, has some environment variables that you have either created or sourced from the bash and so on. So they can be sent by default. So the value of the following variables will be taken from the environment of the QSub command. Okay, so some variables will automatically go from there to the compute node when you run the QSub command. There are some additional environment variables available. So for example, we were using one of these called PBS node file, right? So it clearly says the name of the file contain a list of the nodes assigned to the job for parallel and cluster file system. So this environment variable contains the name of a file. So we use the cat command. Cat is used for detailing the contents of a file. So we said cat dollar PBS node file. So PBS node file was the name of the file that contains information about the compute node. So you printed that on the screen and then you redirected that to another file called machine.list. That is what we did. So go through all these environment variables which are available. I mean, they won't be available in, if you're using things on your local machine, but on the HPC through the PBS, through the Torque PBS scheduler that we have, these become available for your help. So an example would be, in fact, I've given you that as an exercise, and as an advanced exercise. So let's say you have lots of compute nodes, but you know that some series of that, so between N120 and 125, the Python version is slightly different, but you know that already. So, but you don't know where your job will go. So you can put a conditional. So you can extract the information about where your job went. Then inside that script in bash, you can have if loops, if conditionals. So you can put a conditional there that if my job went to any node other than, or if my job went to the nodes between 120 and 125, you run the command python 2 something. Or if not, then you run python 3, whatever it is. So my point is that you can put conditionals, but it becomes very useful because in some cases, it may happen that some nodes have a larger memory. So you can utilize all that memory, right? So you can tailor your bash script through some conditionals in bash, your PBS script through some conditionals in bash, so that you can utilize the complete memory that is required. But that is only possible if you get the information about which node your job went to, and that is possible through this PBS node file. Okay, so you can do very interesting things with these environment variables. But to start with, start simple. And then it specifies the options available. So there are lots of those. I'll only discuss the ones which are more useful for us right now. So for example, -h. So -h will put a hold on the job. For some reason, you want to send it to the QSub, but you don't want it to run yet. Okay, so you have 20 jobs. You put -h with the QSub command, QSub -h followed by the script name. They'll all go on hold. Or maybe the cluster is not working on full capacity. You got an email from the admin that the cluster is 20% of compute nodes are working, 80% are switched off because of the some power AC failure or something. You don't want to clog it because otherwise it will take a very long time in the queue. So what you do is you hold it, and as soon as you get an email that the cluster is back up again, you release them all. Queue release all, and then it will release all the hold jobs. So this -h hold can be used. -I is very useful. In fact, I will demo it today. It's for interactive runs. So you can actually interactively, like you did in IPython. In IPython, you go there and you start doing things and you start getting results. You can do that in cluster as well. So if you send a PBS script with a -I option, what will happen is it will go to the compute node. It will not run anything. It will just take you to compute node, but it has taken you to the compute node through the scheduler. So now you can do things on the compute node manually. Somebody asked me that can we take commands from the user, so you can do that if you want to test it. But it's only for testing because you don't want to be interactively doing things all the time on a cluster. But this is for testing, so you can do that. So minus J is for joining. So standard input and standard error and outputs. Out.e and out.o was what I was using. In the PBS, in the serial script that you saw on HPC website, it uses a minus J. Okay, so minus J is for combining both output and error. Because if you run a Python code on the screen in your laptop, the error and output both are displayed on the same shell. So you can combine them into one. But I usually keep them separate because I want to see whether my out.e is empty or not. That's just for my, because I've written another script because I don't want to, because if you're running too many codes, you want to automate things as much as possible. So if I'm running 20 codes through a job array and I want to see which ones failed, which ones did not, I have another script that runs after all the codes have completed, and that script checks if the out.e was empty or not. If the out.e was not empty, then it sends me an email saying that this job failed. So then I only have to look at that particular job if I'm running too many of those. But that's the level of automation you can do only after reaching a stage where you know how these things are done. But this is for combining output and error if you would like that. So that you don't have to open .e and .o separately. So let's move on with some other options. So minus L is the most important command for us. It's a resource list. So here you can specify how many nodes, how many cores. You can specify even wall time, because the serial script that you downloaded, it's saying that I want to run this command for 10 minutes. So what that means is it will allocate 10 minutes of compute time, and once the 10 minutes are over, your job will close. So it's useful because sometimes what happens is if you ask for 24 hours, but there are some scripts, if you ask for only 2 minutes, it will give you 2 minutes quickly. So if you want to run a job that only takes half a minute, there's no point asking for by default 1 full day or 10 hours or so on. You ask for 2 minutes or you ask for 3 minutes, and then it will take you to the queue quickly. So that's how the queue system is designed. So if you require less resource, then we'll give it to you quickly. The answer, you will get it quickly. You can control that. In some cases, you can control which node your job goes to. So let's say by default it will give me some node, but I want to go to N125 because I know that is where the software is installed. So you can ask that. But then what will happen is whenever N125 is available, it will put you there. How does it decide whether you should be taken there or not? That is internal to the queuing algorithms. But if you really want that, you can ask for a particular node. It will only give you that node when that is available. So that all this resourcing can be done through minus L command. So that's one of the most important commands in QSub. Then mail options if you want to generate emails and so on. So let's not worry about that now. Again, minus capital N is for the name for the job. So I think we already used that. So it will give a name to the job if you want to refer to the job if you're running lots of those. Now there's a priority. Again, don't touch it. Sometimes you yourself you have a priority on a job, so you can specify that. And then if that is available on the scheduler, I think ours does not include that. But anyways, I mean, if the priority is enabled, then what happens is if you have a high priority job, you want to generate the results quickly in a day, then you can use it. So that may be linked to your payment accounts and so on. So if you run a high priority job, it may take money from your account. And on the Param Himalaya, we do that. So if you have a high priority job, then you ask for high priority. It will be charged, but you will get access quickly. But if it's a low priority job, you don't do anything. It will go to the queue whenever the queue is available. So these things can be controlled. But again, as a first level user, you don't need to touch these things. So minus Q is for the queue. There are multiple queues available as I showed, and you were using serial. That only gives you one core access. Now there's a minus T with an array. So if you have a job array of 50 jobs, you can create an array of jobs. So let's say you are running a code. It's a design-based calculation. So you have, let's say, a molecular dynamics code. You want to run it for, you're doing a scaling analysis. So you want to run it for 20 particles, 200 particles, 2000 particles, and so on. So what you will do is the first thing that comes to mind is you generate lots of scripts. Each script has a different number of particles in it that is passed through the code, and you run them separately. But you can do it through the job array. So in job array, what happens is you generate a sequence of integers, ranging starting from 20 all the way to 2 million, and you can pass them into one job as different. So each integer will be passed as an input to the array. So you can basically create some sort of a loop in that, and they will be sent as different jobs to the cluster. So this is very useful if you have production runs on lots of parametric studies or so on. So on. Okay. Again, first level users don't worry about these things. And then minus v is all the environment variables are sent to the compute node. So by default, only a few of those are sent if you look at the beginning of the QSub manual. But if you want to send all of them, then you can use the minus v command. So we use the minus v command, minus v option, to send all the environment variables from our bash shell in the head node that we are using to the compute node. Right, and then we don't need to worry about this. Minus capital X is for X forwarding. It's very slow, but if you want to run a Jupyter notebook, you can do that interactively. So what will happen is it will open a Firefox on the compute node, and then it will send it through the head node to your local machine. That will be so slow that there's no point running Jupyter notebook on the compute node. But if you have a cluster which is very quick in terms, because we are in South Campus A9 building, we are actually developing an HPC lab on the top of the cluster. The cluster is in the basement. Above that, we have an HPC lab. So it's a glass building. People who live in South Campus may have seen that beautiful building of glass. So inside that, we'll very soon have computers which are heavy-duty machines with 128 gigabytes of RAM and Xeon processors and so on. And these are just used for interacting with the cluster mostly. So what you can do is, if you have large amount of data that you want to copy from the cluster quickly, or you want to do something interactively in the cluster, so that the communication with the cluster is much quicker than if you're doing it from here. Okay, so you can enable X11 forwarding. So display will get forwarded from your compute node via the head node to your local machine. So if we get time, I'll show you that, but it is not much useful because of the slow speeds. And minus X is if you're running interactive jobs. So let's do that. Let's run an interactive job and I'll show you. Any questions, by the way, till now? Yeah, so you have two file systems. If I go to my home and say an ls, everything that you see is in home. Okay, except this wd folder. So if I do an ls minus so if we look at wd, it actually is a link to this folder called /wd/users/my username. So that's the file system for working directory. You have 2 terabytes there. They're slightly slower, but everything else that you see inside the home that you have is you get only a small amount of space. I have to check how much it is. It's less than half a gig, but I think it's 1 gig. But that's much quicker. So if you want to store your scripts, you would want to store your virtual environments and so on. You can store them in the home. If you are generating, let's say you're doing molecular dynamics, each simulation will generate at every time snap. It will generate 1 gigabytes of an output file. So that has to go to WD. If you clog your home, your account will become inoperable. So home is for storing some scripts and all, not for data files as such. Okay, so let's remove this output files and also remove the machine list. So what now I want to do is I want to run something interactively on the HPC through IPython. Okay, let's say I want my HPC is really good, the compute node. I want to do something on the IPython just to check things. So if I use QSub and I'm using the same script, okay, this script PBS. Let's look at the script again. So if you run a job interactively, what happens is it only uses these commands and it ignores the bash commands below it. So when I run something interactively, basically I am only using these commands. Okay. So let's run it. So qsub with a minus capital I and then the script name. So now it says waiting for job to start, and the job has started, and you see it now takes me to N115 instead of taking me back to head node because now the job is running. So if I do a qstat, it says R. The job is running. I've taken time on. I've taken one core because that initial directives ran. So it gave me through a serial queue. It gave me one core on N115 legally. If you do SSH to N115 and start running something there, that is illegally. Your account may get, if we catch you, and most probably we will, your account will get deactivated. Okay, so we legally went through the -I interactive shell. So the queue manager gave us access to N115, and if N115, let's say, has 8 cores in it, so it will not allow more than 8 jobs. So that way, if somebody logs in manually and tries to run it, it will basically slow their job and my job. They have to share time. So the threads will be shared. So that way, now I am on the interactively on the compute node N115. I can do whatever I want. So I can let's activate our virtual environment. Now I can start IPython shell. So it starts IPython. I'm still on N115. So I can do things, and I can, let's say we want to import okay, so things are working. Okay. I just want to show you that. And when you are done, then you type exit. It takes you out, and it says the job has completed. So if I do a qstat now, it shows the job completed. Clear? Any questions on that? And this information is available on the HPC website also, so you can look at those things. Now, sometimes what happens is we are sent. Yes.
So with the -I command, you basically started using that node as your computer.
Yes. Yes. Yeah. Interactively. Now, sometimes what happens is I would want to in the script I want to modify something. So let's say in this case I'm running it. In the resources, I would want to specify, or let's say I want to force it to go to a certain node, let's say N115. So I'll say nodes equal to, and then I'll say N115, and the complete path to it, cluster.iit Mandi.ac. So what this does is, it will force things to that particular node. So let's save it and run it. Now I won't run it. Well, let's run it interactively. So it took me to N115. Now let's say I want to go to N116. And I don't want to change the script again and again. I just want to type it here. So what I'll do is, I'll write -L. And then I'll write nodes equal to N116. So probably N116 is not available, so I'll have to wait as soon as the queue manager allocates it, but that's okay. Now I will say cancel it. Let's try N117. You can't see that. You can't see. Top is for going inside a node and seeing what all people are running inside that node. They're not available. But the point is that you can force things, and I don't need to do it interactively. I can just send a job and then go home. So you can see that it is in the queue. So if I do queue start minus an, so it's still in the queue. In fact, there are now. Let's go to QStat. Okay? I think I've given you enough information about QSub to control. But let's say your job has gone, and then now you want to see some details about the jobs that have run, the jobs that are in the queue, the jobs that are running, and so on. So there's a command called QStat for this. So let's. So QStat, we were using QStat with a minus an. So A is for all jobs. Okay, you can also specify a job ID and it will only tell you the status about that job. If you do a minus a, it will tell you the status of all the jobs. And n is to display the nodes allocated to the job. So if I do it without the nodes, so if I do a QStat, then it won't tell me where the job ran. But if I do a QStat with a minus n, then for example on this job which already completed, it says it ran on n115. You can extract as much information you want. And if I do a manual for QStat, then it tells me everything that's available. Okay. So if I do a minus f, that's a full status. It can be quite descriptive. But let's look at it for one particular job. So let's say the one that is still in queue, this 381049. Okay, so it only tells me information about that job. And now I do a minus f, full information. So now there's plenty of information available for this. So it tells me the job ID. It tells me the job name, who is the owner, the job status, it's still in queue. What is the queue name it was sent to? What is the server that was used to send it to? Checkpointing details, some time details, some error paths. Is there a hold on the job? Okay. Was there a join of output and error files done, and so on? So basically everything that you require for a job is available, the full information about a particular job. How many CPUs you want, how many nodes you want, where is it sent to? It's sent to N120. I think that's what we used. We forced it to N120 through the -L command in the QSub options. So it's waiting for N120. That's useful because you can now clearly see where your job went. Okay. Resource list. So I asked for default. Default is 1440 hours. I could have taken lesser time. So we can do that. So let's quit. Let's queue del. Let's delete this job from the queue. So if I do a QStat, job's gone. There's no job in the queue now. And now, well, it did generate an out.e, which is nothing. Let's remove these output files. So now here, what I'll do is, I'll also force it with a -L, and I'll say that I want wall time equal to 0 hours, 0 minutes, 5 seconds. It's still in the queue, but if I do a QStat followed by the job ID with the -F. So let's look at the details of this job. So the resource list is still 120, so it's gone to 120, but it only requires 5 seconds this time. So what happens is After 5 seconds, it will just kill the job. So be careful with these things. Now sometimes there's a default also 1440 hours. So if you're running a code which requires 10 days and you only have 1 day available in the cluster, so what you do is you create checkpoints. For example, in a molecular dynamics code, you will generate time snapshots in terms of file details. So each file will contain the phase, the state variables of all the particles. So the position, velocity, acceleration, and so on. And then if you want to start it again, you can start it again starting from that initialization. But that's a fair usage policy for each queue. So after 1 day, it will kill, and then it will go to the next. So if you want to run it again, then you have to send it again, and that will go into the back of the queue again. Okay, so you can explore this option further if you want. So that's a full detail of. So A is for all. Again, I'll only discuss the ones which are useful to us at this stage, but feel free to explore. Minus N is for the node details. Now it will display the size information is displayed in terms of bytes. If you want it more human readable, you can do a minus G or a minus M. So it will generate size in terms of gigabytes or megabytes for easy readability. If you have a job array, you can use some options to understand the information about the different array contents of jobs. So there is a minus Q option also available. Let's try that. So if I do a Q stat with the minus Q option, it will give me detail. I think I showed you already. So it will give details of all the queues that are available. So minus capital Q is a bit more descriptive. Okay, and then in the queue we have some private queues also. So if a colleague contributes nodes from their projects and all, so we give them a private queue. So you can access that as a general user, but if that person requests a job, then your job will put on hold, suspended, and that person's job starts. So it's at your own risk. If all the queues are full, you have no access, you can use a queue called a low PR, low priority queue. So if one of the private nodes of somebody's are available, your job will go there. But as soon as they request a job to their own private queue where they have privileged access, then your job will be suspended. So I use this low PR queue to use people's private nodes. But what I do is my codes are generating checkpoints very frequently. So if after half a day it gets suspended, I have some results available, so I can use those results and start from there. That's pretty much it for QStat. Right. Any questions? There's a command called PBS nodes. So it gives me information about all the nodes that are there in the cluster. So if you want to know what are the resources available, rather than asking me or the administrator, you can see N127 has 16 cores available, what jobs are running and so on, or what jobs have run. And so these details, and where is it mapped to? So it's mapped to Gen. So which queue is it mapped to? So you can look at those details also with a bit of an understanding of how these commands work. So if you have any questions, you can always go to search for torque PBS. That's the scheduler we use. All the commands available in torque PBS are available. So most of the information what you need is available to to you openly. You can just access the right command for that. These I've discussed. And qdel is used to delete a job, and if you do qdel all, it will delete all jobs which are either running or queued or whatever. And interactively, I have discussed as well. So minus I command, that's done. So here's an exercise for you. Partly you have already done it. This is a, so there are two exercises. One is an exercise one, which is basic, and exercise two is a bit more advanced. Exercise two will take you a lot of time, so more sort of homework. Exercise one is very basic. I expect you to be able to do it. So from next lab onwards, I'll do a viva with you. So I'll be writing some marks as well, just to understand what sort of understanding you're developing in this course. If you're not asking questions and still not understanding, so that's a red mark for me. If you are confused in asking questions and then you are clear about things, so that means you're moving forward. Okay, so exercise one is to log into the cluster. You have to copy. So for copy, we use an scp command. Okay, so let me show you that. So I'm on the cluster right now. So let me open another window, and let's say I have let me create a file, temp copy. So touch is just to get an empty file. So let's put some text in it. I'll save it. So if I do a cat on temp copy, so it says that text is over. So this is my local machine. I want to copy it, so I'll do an SCP. So it's a copy over the SSH protocol. My username @ 10.8.1.19, and then I have to put a colon to tell that it has to go to the home directory of that. But I have to give the file name as well. So I'll specify temp copy. So I'm copying securely temp copy to my username @ CPU HPC's IP with a colon, that means home. In fact, I can specify the complete path, but let's put it on home. So it asks the password for my HPC cluster. So once we do that, it says it's copied temp copy at some speed and all. So if I go back to my cluster now, and I do an ls in my home as temp copy, so there it is there. So I can actually cat it. So it prints it. So that file was copied successfully. Now if I want to move it to my home, to my current folder, so I can just copy it from home to the current folder. So now in this folder, this temp copy is available. So that's how you copy files. So in the assignment, you're supposed to copy the mysquareroot.py that we developed. And then you copy a sample serial script from the HPC website. So right now what you did was you copied the text and used Vim on the HPC and copied it. You can also copy the file from HPC website, and then you can securely copy it to the HPC cluster from your laptop. So what the exercise requires you is to create a file called root.py, and that file root.py should be able to call square root mysquareroot.py to calculate the square root of 2, and you keep the debug mode on. So basically we are using the mysquareroot.py to calculate square root of 2 with the debug mode on, and the output should be redirected to a file. Should not be redirected, so the output should be displayed in out.o. So we want the output to go into out.o, and then you launch the script using qsub on CPU HPC. Okay, and you try it with a different queue. So try it with a day queue or infinite queue and see what happens. Right now we are using serial queue, and then you launch the script on GPU HPC also, 10.8.1.20. So let's try that. So let's open a new tab on my laptop, and we'll say SSH my username at 10.8.1.20. So if I do a qstat minus q here, the queues are different. That's the whole thing I want to impress upon you, that the queues on the GPU cluster which is actually N65. It's not N199. That is for head node for the CPU cluster. The head node for the GPU cluster is N65. So the queues are GPU queue, which is open to all, and then we have some private queues, which are people's private queues or schools' private queues, and then we have some low priority queue, as I said, which is used for using private queues of others if they are available free. They're freely available at that time. Okay. So try both clusters and see what happens, and then you try to run the command interactively on through the -i command. See what happens. Try different QStat options. Try to see PBS nodes option for node mapping, which node is mapped to which queue and so on. And then once you're happy, once everything has run, you copy the output files back from the HPC cluster to your local machine. Because that is also you would want. You would want to copy the results back to your machine so that you can store them, you can process them and so on. If you want to plot it using some plotting tool, you do it on the local machine. HPC is not useful with that. And as an added challenge, you write a bash conditional that should only run the code if your job goes to N121. Okay, so I told you that PBS nodes can be used for some conditional checks as well. So if your job goes to N121 or any node for that matter, you only run that. So you can put a conditional if condition in a bash loop, in a bash conditional inside the script, PBS script that you have. And how do you check it? Well, you can check it by forcing the code to N121 through the -l nodes equal to that command. That we did because I forced the code to a particular node. So you can force it and see if that script is working properly. Because if you send it by default, the probability of it going automatically to N121 is very low. It will go anywhere. Okay. So this is exercise 1. Exercise 2 is a bit more complicated. So I'll say that it will take some time. So you have to create multiple jobs and use bash loops inside the PBS script and so on. Then take your time. If you have any confusion, if you start working on this, you have questions, you can ask. So I think it's time now. We'll stop. If anybody has a question, I'm happy to answer.